First, we should learn about on what factors does the boiling point depends on. Boiling point mainly depends on three factors. They are intermolecular attractions, that means secondary interactions in the molecules, and molar mass and surface area. That means when we are finding the highest boiling point from given compounds, we should mainly focus on secondary interactions. Then, secondly, molar masses. Thirdly, surface area. Now, let's recall our memory about secondary bonds. We know the secondary bond with highest energy is iron dipole bonds. Then hydrogen bond, which is a special dipole type. Then dipole bonds. Then iron induced dipole bonds. Then dipole induced. Lastly, the least energy is among dispersion forces. I said that when we are finding the highest boiling point, we should focus on the secondary bonds first. Now let's see what type of secondary bonds in these elements. We know helium, neon, methane and N2 all has London forces. These four has London bonds, and this carbon monoxide has dipole secondary interaction. So from that above we learned that dipole interactions energy is higher than the London forces energy. So according to that, we know carbon monoxide is the highest boiling point. So number 5 is the answer. Now let's further analyze the other compounds other than the carbon monoxide. We know after the secondary bonds we focus into the molar mass. Now we can see that nitrogen has the highest molar mass among these four compounds. So after the carbon monoxide, the highest boiling point is nitrogen. Then neon, then methane, as helium. Already discussed how secondary bonds and molar mass of a compound affects boiling point. Now let's see how surface area of a compound affects boiling point. As you can see, when branching of a long carbon chain, it decreases its surface area. So the longest carbon chain is the highest surface area compound. So that's the compound with highest boiling point. The more branched, the surface area will decrease. So as you can see, the boiling point is decreasing as the surface area also decreasing. We already know carbon monoxide is the highest boiling point compound as it has secondary dipole bonds. Many of you will confuse the answer as nitrogen because of this triple bond. You have to know that primary bonds do not affect the boiling point. The bonds affect the boiling points will be these secondary bonds among nitrogen molecules. So now I think you have a clear idea how carbon monoxide is the compound with highest boiling point, not nitrogen.